Hey guys, happy Wednesday. Today we're going to be learning about something that is super relevant. We're going to be learning about infectious agents. So this is super relevant to what we're going through right now with COVID-19, and maybe it will help give you a better understanding of what's happening and why it's important that we are social distancing. And we can talk a little bit more specifically about that if you have any questions in tutoring. So before we start, remember that I have tutoring on Tuesdays at 3 p.m. and Thursdays at 9 a.m. To go over the work that I assigned previously. Your weekly assignments are posted on Mondays and on Wednesdays and are due on Fridays. So let me kind of reiterate our schedule for science. Monday, you will get one assignment posted to you. Tuesday is tutoring to help with that assignment. Wednesday is your second lesson for science for the week. Thursday is tutoring. And then Friday, your assignments are due. So you have a little bit of flexibility. So I'm going to start sharing my screen with you. You should have printed out or have the infectious agents guided notes open and you can edit them. I saw a lot of people just writing the fill in the blank part. I cannot give you full credit for just writing the fill in the blank. It won't help if I just write random words in the blanks. It'll only help me learn if I have all of the information. So if you are just writing the fill in the blanks, you will not get full credit. Please either print out the notes and write on them, or edit them in Microsoft Word or Adobe Acrobat. These specific notes are actually not under Unit 5. They are under Unit 6. And again, I will show you that. I'm just kind of moving this up a little bit because I feel like it's super relevant, and we just learned about the human body a little bit, or living systems, in Monday's study island. So just looking over the website, there's the blank notes. Always check my homepage. It has what's due for the week, and I will put the video for today, the link up there. If you go to coursework, we are currently on Unit 5, but remember these infectious agents notes I said are under Unit 6. And then if you scroll down, what else cool stuff we're going to learn? There's the guided notes reading, which this is where this comes from. You don't have to do the reading. It is very interesting, but it is very long. So that's why I'm just going to go over them with you. Here are the guided notes themselves, and then the completed copy. So please look at Unit 6 if you have any questions, and you can check yours against mine. All right. So let's go ahead and get started. Remember, we're always going to put our name at the top. I have some people who weren't putting their names, and it's hard to identify because your emails aren't the same. So just help me out with that. And our do now, this is actually from something we would be doing in class, but a microorganism, the word micro means small. And an organism, that, as we've learned last week in our 6 characteristics of life guided notes, an organism is a living thing. So when I put these together, a microorganism is a small living thing. And so small, so it's so small that I actually can't see it with the naked eye. Like a microscope, you need a microscope to see a microorganism. So there's 4 different kinds of infectious agents that we're going to be talking about. The first is bacteria, and we have 2 different kinds of bacteria. The first kind is pathogenic, and the second kind is non-pathogenic. So you may have heard the word like pathogen or the word pathogen before. If something is a pathogen, it means it is capable of causing illness. So this is a bacteria that can make you sick. We have non-pathogenic bacteria in our stomach that's really good for breaking down foods. That would be considered non-pathogenic because it is not likely to cause illness. I want you to think of like bacteria in our stomach. Or sometimes we even use bacteria to break down other organisms, but it's not going to make them sick. So I also want to let you know that pathogen is a germal organism. That can cause illness. So if something is a pathogen, it has the potential to make you sick, like the P, potential, whereas a non-pathogenic does not likely to make you sick. Bacteria are simple organisms, so they're not very complex living things. They're very simple, and they're made up of one cell. So this goes back to our classification where we were talking about organization of cells. This would be considered unicellular. Uni meaning one. And that's how bacteria are organized. So they would automatically be classified into that group. Some bacteria are pathogenic and can cause disease or illness, either because they end up in the wrong place, in the body, so they could be in the wrong place. Remember I said we have bacteria that's in our stomach. So sometimes bacteria can go in the wrong place, or simply because they were designed to invade us. And this is like, one example is meningitis. So meningitis can be viral or bacterial. And if it's bacterial, that's actually much better than viral, and I'll explain why in a little bit. But those kinds of bacteria are designed to be harmful. Whereas some bacteria is not, it just ends up being harmful because it's not in the right spot. It's kind of like when you dislocate a bone and it's uncomfortable just because it's not in the right spot. The same thing can happen with bacteria. It is important to note that some bacteria may have non-pathogenic and pathogenic strains. So some bacteria may have a version that can make you sick, and then may have a version that cannot make you sick. So it just depends on the strain. And what I mean by strain is the specific type. There are some small variances in these unicellular organisms. This is the reason why I said bacterial meningitis is better than viral, because bacteria tends to be vulnerable to an antibiotic. And the word vulnerable, I want you to know, it means like it can be weakened. Like it can be hurt by an antibiotic. And that's good because viruses can't be treated by antibiotics. So if you have a virus, you always have it. You always have like part of it. It's just active or not active. Whereas a bacteria, you can get rid of all the way because there's an antibiotic or a medicine. Some of you may have had to take an antibiotic if you had strep throat, and it'll go away. I do want you to know that the prefix anti means against. And we know from our Earth spheres that bio means life. So antibiotic means like against life. Like it's going to try to kill it. It is also important to understand that bacteria can become resistant to antibiotics. And that can be dangerous because if you take antibiotics too much, the bacteria will get stronger and stronger. So they have had to develop new antibiotics as bacteria evolve. Now, because bacteria is a living thing, it adapts to its environment. So if we are always trying to kill it, it's going to adapt and try to resist us killing it. So it's always like a constant fight to find a new antibiotic that is going to treat bacteria that has become resistant. So for those of you that are interested in medicine, that's a really cool thing to look into because we're always looking for the development of new medicine. So some examples of pathogenic and non-pathogenic bacteria would be E. coli, which can come from food. There's both a pathogenic and non-pathogenic strain. You also have whooping cough, which they look out for in babies. Tetanus, which is if like you step on a rusty nail. You always get a tetanus shot just in case because the rust can have that bacteria. Scarlet fever, these are older ones. And then I don't know if you guys have ever played Oregon Trail, but dysentery was an illness that a lot of families would die for when they were traveling back in the old days. And it's just a bacterial infection. Viruses, on the other hand, viruses are much smaller and they're much more complex. They're much more complex, which is why it's harder to treat a virus because not only are they resistant to antibiotics, they don't because they also change a lot faster and replicate faster. And this is the scary part. They can survive outside of the body for a period of time. So that's the scary part is that they don't need a host. They can survive outside the body for a little bit, and they are not affected by antibiotics. Viruses cannot reproduce or multiply on their own, however. So even though they can live outside the body, they can't reproduce on their own. They have to invade a host cell to take over and then make copies. So the idea is like bacteria can replicate on its own and make new bacteria and make new bacteria and make new bacteria. Viruses can't unless they're already attached to a cell inside of our bodies, and then they can use that cell. It's like when in the episode of SpongeBob, when Plankton goes in SpongeBob's head and starts controlling him. That's kind of how viruses act. The viruses take control of the other cell and they tell them, start making more copies, and then the virus can replicate. But it can't replicate on its own. So that's a good thing. Unless it has a host, it can't reproduce, which is a characteristic of life. So very interesting. We'll talk about whether or not we think viruses are alive or not. So anyway, viruses cannot reproduce and multiply on their own, so they invade a host cell and take over its machinery or take over the control center in order to make more virus particles. They do this by latching onto human cells and getting inside them. So like I said, it reminds me a lot of the episode of SpongeBob where Plankton goes in SpongeBob's head and starts controlling him. It's like he's the virus, like Plankton's the virus. Viruses consist of genetic material, genetic meaning like what makes us, like our DNA, our genes. So this is DNA and RNA. We'll learn more about this in Unit 6. RNA is like DNA's messenger. And DNA we know is what is like our blueprint, what makes us us and special and unique. The part of our body that is specifically or most susceptible to attack by viruses is something called our mucous membrane. We have these in our noses. It's where our mucus comes from. And that's because they're not protected by a layer, like anything or any layer. Like whereas our face and stuff like that are protected by skin, our mucous membranes are like as soon as we go into our nose, they're there. So that's why it's always important that you're washing your hands, especially before you all pick your nose or touch your face. So make sure that you guys are continuing to do that. And what must be done to kill a virus? The invaded cell or the host cell must be killed. So the idea is the cell that was taken over by the virus has to be killed in order for the virus to be killed. Because let's say that the virus kept replicating and replicating and replicating. It's going to keep replicating until the host cell or the invaded cell is killed, and it doesn't have the means to keep reproducing. There's actually something inside of us called white blood cells. So we have red blood cells and white blood cells, and we'll get into that in the next unit. Our white blood cells actually are like our fighters. They're made in our immune system, in our lymph nodes, and we have a bunch of lymph nodes, and we'll talk about that in the next unit. But white blood cells prevent new cells from being invaded. They're almost like police officers inside of our body, and they kill the virus before it finds a new host cell. So what needs to be done to kill a virus? The invaded cell must be killed, and then white blood cells help to finish it off, which is pretty cool that we have those mechanisms inside of our bodies. A couple different examples of viruses. The cold and flu is actually a virus. Chicken pox is a virus. So I had chicken pox when I was younger, and I still have the virus inside of me. It's not dead. It just isn't active. So that means when I get older, I can get something called shingles, which is in the same family. It just means I'm more susceptible. Cold sores, so like when we get them on our lips and stuff, cold sores are a virus. The measles, which we get a vaccine for. The mumps, again, measles and mumps were almost eradicated, but they've actually recently come back. And there was like an outbreak up north, I believe. So you actually get a vaccine for that when you're younger. Warts are a virus. They don't come from touching frogs. That's what I was told when I was little. That's not true. It's actually a virus. And then norovirus, which is a typical. So pretty cool that bacteria and viruses are so different. Bacteria do replicate on their own. They're unicellular organisms. They produce their own food. Uh, and they follow all 6 characteristics of life, whereas viruses don't. So very, very interesting. This is the part that might gross you out. So just bear with me. Parasites and fungus. Pathogenic fungi can either be yeast or mold. And we eat mold. If you ever have blue cheese, that's mold. Cheese is typically is aged. So like I said, some fungi or some bacteria are not pathogenic, like blue cheese. It's not going to make us sick, unless you're me. I don't like blue cheese. But if we sometimes use mold to make things and yeast to make things, it's just some is pathogenic and some is not. A fungus is a simple plant-like organism. I always think of mushrooms, but that's not the only kind of fungus. Athlete's foot is a fungus. Unlike plants, fungi do not make their own food. They actually they're like decomposers. They get it from someone else. Some species of fungi get their nutrition by breaking down the remains of dead plants or animals, decomposers, and others are parasites. Fungal infections include ringworm, which a lot of people get from like being on dirty mats like taekwondo or wrestling, or athlete's foot, which you can get from like not changing your socks regularly. And then we also have some parasites, and this is the part that's kind of gross. Some parasites are very complex. Many are pathogenic, meaning that they will make you sick and cause infection that will spread from person to person. parasites usually enter the body through the mouth or the skin. This is the part about parasites that is kind of creepy. They like feed off of you. So like fungus and parasites will feed off of something. Like let's say I get a tick. That tick is feeding off of my blood. Fleas feed off of dogs. Bed bugs feed off of blood. Threadworms, pinworms, scabies. All of these are examples. It's making my skin crawl. But ticks, fleas, scabies, threadworms, pinworms, they attack the intestines. Bed and bed bugs, these are all parasites, so they attack a living thing and feed off of it. Now this is our last section. What does it mean for an infection to originate endogenously? So word endo means inside. So endogenous equals transfers within our own body. Whereas exo, I think about exo or exit, means outside, like exoskeleton is the outside shell or to exit, or exosphere, like you learned about the layers of the atmosphere. So exo means transfers from outside the body, which means like through hands, air, equipment, etc. So like touching a doorknob that somebody else touched after they sneezed. The difference between infectious and infectious disease means that it can spread. So like COVID is infectious, whereas non-infectious disease cannot spread. So like an example of non-infectious, like if I'm around someone who has cancer, I'm not going to get cancer just because I'm around them. So it means it cannot spread. So not all diseases are infectious. Diabetes is not infectious, but it is a disease. So there is a difference. And then cross-contamination. We know the word contamination means to be altered, or so if I contaminated a recipe, it means I altered it or made an error. Or cross-contamination means like across lines. So cross-contamination is when an infection is moved from the source to another location, and then another person. So this would be like sneezing, like I said, sneezing in your hand, and then actually move it down. So like sneezing in your hand, and then touching a doorknob. And then another person touching the knob. So that's why it's super important that everybody washes their hands. Now this is our exit ticket. Based off of what we talked about, I want you to answer this yourself. We know that the 6 characteristics of life have to be met for something to be considered alive. So I want you to reference the 6 characteristics of life to answer this. And this is, remember, those notes are already on, or you should have already completed them. So reference those 6 characteristics of life. How is it organized? How does it obtain food and use energy? How does it maintain homeostasis? How does it reproduce? And we're specifically talking about how is it, how do all those 6 characteristics apply? We're specifically talking about viruses. So I want you to tell me, essentially, do viruses meet the 6 characteristics of life? If you do not answer this one on your own, you will not get full credit for today's lesson. So, and I want you to tell me why or why not. You need to be able to explain your thinking to me. So all of the notes are completed. Remember, I cannot have you just submit the fill in the blanks. So you need to either print this out or edit it on the screen. Remember, I have tutoring tomorrow at 9 a.m. I hope to see you there. And I hope you guys have a great day. I'll talk to you soon.